For centuries, humanity has gazed into the night sky, wondering what lies beyond the veil of darkness. For a long time, our capabilities were limited, but the launch of the James Webb Space Telescope changed the game. This is not just a mirror in space. It is a time machine capable of capturing light that originated over 13 billion years ago. We finally have a tool that allows us to peer into the cosmic dark ages, an era when there wasn't a single star in the universe, and witness the moment of their first triumphant appearance. To understand the scale of this achievement, one must realize how complex the journey was. Webb is the most expensive and sophisticated instrument ever created by man to operate outside of Earth. Its journey to the L2 Lagrange point, located 1.5 million kilometers away, was fraught with risk. The slightest error in deploying its massive golden mirror or its tennis court-sized Sunshield would have turned a $10 billion project into space junk. But engineering prevailed, and today we see the first results of this daring mission. The first images transmitted by the telescope sent shockwaves through the scientific world. Where we once saw only void or blurry spots, Webb revealed thousands of galaxies, each containing billions of stars. Its infrared vision pierces through dense clouds of cosmic dust, revealing the pillars of creation and stellar nurseries in a resolution previously thought impossible. We aren't just looking at pretty pictures. We are studying the chemical composition of distant planets' atmospheres, searching for signs of life that might have been hidden from us forever. One of Webb's most ambitious goals is to study the early galaxies formed just a few 100 million years after the Big Bang. These cosmic pioneers look nothing like our majestic spiral Milky Way. They are smaller, more chaotic, and filled with massive, hot, first-generation stars. By looking at them, we are literally seeing our own past. The telescope captures light that has been stretching for billions of years, shifting from the visible spectrum into the infrared due to the expansion of the universe, a phenomenon known as redshift. But Webb looks not only into the distance, but also deep into objects already familiar to us. The famous pillars of creation in the Eagle Nebula, previously hidden behind a thick curtain of dust, have appeared before us in an entirely new light. Where the Hubble telescope saw only impenetrable walls of gas, Webb's infrared detectors spotted thousands of newborn stars shimmering like jewels. These massive columns of cold interstellar gas and dust are true forges of worlds, where new solar systems are being born right now under the influence of gravity. However, perhaps the most intriguing direction of the telescope's work is the search for exoplanets, worlds orbiting other stars. Webb possesses the unique ability to perform spectroscopy on the atmospheres of these planets. When a planet passes in front of its star, its atmosphere filters the starlight, leaving unique chemical fingerprints. Webb has already found traces of water, methane, and carbon dioxide in the atmospheres of distant gas giants and rocky worlds. This brings us closer to answering the ultimate question: are we alone in the universe? Or is there a planet out there, among billions of stars, much like Earth? Scientists are paying special attention to the TRAPPIST-1 system, where 7 Earth-sized rocky planets orbit a red dwarf. 3 of them are in the so-called habitable zone, where conditions might allow for liquid water on the surface. Webb has begun a detailed study of these worlds, trying to find out if they have atmospheres and whether they haven't been stripped away by the harsh radiation of their star. Every new observation in this system is a step toward discovering a habitable world that could radically change our understanding of biology on a cosmic scale. But Webb doesn't just look into the deep past. It also observes neighbors in our own solar system. Its images of Jupiter and Saturn have amazed researchers with their detail. Thanks to infrared filters, we have seen giant auroras at Jupiter's poles and the finest structures in its rings that are nearly invisible to conventional telescopes. Webb is also studying icy moons like Europa and Enceladus, which hide global oceans beneath their frozen shells. The telescope is searching for traces of organic compounds in the geysers erupting from these mysterious worlds. One of the biggest mysteries Webb is trying to solve is the nature of dark matter and dark energy. Although we cannot see them directly, The telescope observes how their gravity distorts light from distant galaxies. This phenomenon is called gravitational lensing. Huge clusters of galaxies act like giant magnifying glasses created by nature itself. By studying these distortions, scientists hope to understand how invisible mass is distributed in the universe and why the expansion of the cosmos is constantly accelerating, contrary to the laws of physics as we know them. To achieve such incredible sensitivity, Webb must operate in conditions of extreme cold. Its operating temperature is about -233 degrees Celsius. To achieve this, engineers developed a unique 5-layer sunshield made of Kapton. The thickness of each layer does not exceed that of a human hair. While the side facing the sun can reach 110 degrees Celsius, in the shade of the shield, the telescope's instruments remain cold enough to capture the heat radiation from the very first stars that ignited in the darkness of the newborn universe. The heart of the telescope is its massive primary mirror, 6.5 meters in diameter. It consists of 18 hexagonal segments made of lightweight beryllium and coated with a thin layer of gold. Gold was not chosen for beauty. It reflects infrared light better than anything else, allowing the telescope to gather maximum information from the depths of space. Each of these segments is equipped with microscopic actuators that can adjust their position with nanometer precision. This allows scientists to focus on objects millions of times fainter than what the human eye can see. Every image we receive from Webb is not just a beautiful picture, but a massive array of data. Scientists spend weeks and months processing this information. The primary images in the infrared range are invisible to humans, so specialists assign specific colors to different wavelengths. This gives birth to a visualization that allows us to see the structure of interstellar gas, energy flows, and shadows of cosmic dust. These images are changing not only science but culture, becoming new icons of our time and reminding us of how deeply we can peer into the mysteries of creation. One of the most exciting discoveries has been supermassive black holes in the early universe. Webb found that these gravitational monsters existed much earlier than modern models predicted. Some of them have masses millions of times greater than the Sun and are located at the centers of galaxies formed only 500 million years after the Big Bang. This poses a fundamental question for scientists. How did such giants manage to grow so quickly? Perhaps black holes were the seeds around which the first galaxies gathered, rather than appearing as a result of the death of the first stars. The telescope has also allowed us to peer inside protoplanetary disks, clouds of gas and dust surrounding young stars. In these chaotic structures, new worlds are forming right now. Webb has discovered complex organic molecules and water vapor within them. This means that the building blocks for life and entire oceans of water are laid into the foundation of planets even before they are fully formed. We see that our Earth was not a unique case. The processes that created our home are happening everywhere across the galaxy, turning the cosmos into an endless conveyor belt for creating planetary systems. Looking to the future, the Webb mission promises even more incredible breakthroughs. With every year of its service, we will receive increasingly detailed data on the atmospheres of exoplanets like Earth. Perhaps this very telescope will discover technosignatures or biosignatures, irrefutable evidence that we are not alone. Webb is not just a scientific instrument. It is a symbol of our thirst for knowledge, a bridge between a tiny pale blue dot and the boundless ocean of stars. Its legacy will define astronomy for decades to come, forcing us to rewrite physics textbooks and our place in this grand cosmic play. One of the telescope's most shocking finds was the so-called intruder galaxies. According to the classical cosmological model, galaxies in the early universe should have been small and fluffy. However, Webb discovered objects that look as massive and mature as our Milky Way, even though they existed when the universe was only 3% of its current age. This discovery called into question the very theory of how quickly matter can accumulate. Scientists jokingly call them universe breakers because their existence forces us to reconsider the foundations of our understanding of dark matter and how quickly gravity can mold large-scale structures from primordial chaos. Webb also shed light on the mystery of the cosmic dawn, the period when the first stars ionized the hydrogen fog that filled space. Before this moment, the universe was plunged into the dark ages, where light could not travel long distances. Webb's instruments recorded how powerful ultraviolet radiation from the first stars literally burned holes in this fog, making the universe transparent. This process, called reionization, was a crucial stage in the evolution of the cosmos, transforming it from a homogeneous hot gas into the complex and beautiful structure we see today. Webb also shed light on the mystery of the cosmic dawn, the period when the first stars ionized the hydrogen fog that filled space. Before this moment, the universe was plunged into the dark ages, where light could not travel long distances. Webb's instruments recorded how powerful ultraviolet radiation from the first stars literally burned holes in this fog, making the universe transparent. This process, called reionization, was a crucial stage in the evolution of the cosmos, transforming it from a homogeneous hot gas into the complex and beautiful structure we see today. Another incredible area where Webb shines is the study of rogue planets. These are worlds that do not orbit stars, but wander lonely in the icy void of interstellar space. Previously, they were almost impossible to detect, but thanks to Webb's ultra-sensitive infrared sensors, dozens of such objects were found in the Orion Nebula. Some of them have the mass of Jupiter but exist in pairs, which baffles scientists. This discovery forces us to reconsider the theory of planet formation. Perhaps they are not always ejected from their systems, but can be born on their own, directly from collapsing gas clouds, like miniature underdeveloped stars. Webb has also become a true expert on cosmic dust. And although it sounds mundane, this dust is the key to understanding everything. It consists of heavy elements like carbon and silicon, which form in the cores of dying stars and are ejected during supernova explosions. Webb showed us that the early universe was literally packed with this dust much more heavily than we assumed. This means that the cycles of life and death of stars happened incredibly fast, paving the way for the appearance of rocky planets and, ultimately, life. We are literally made of this stardust, which Webb now sees in exquisite detail. One of the telescope's most ambitious tasks remains the search for water in the most unexpected places. Recently, Webb discovered water vapor around a comet located in the main asteroid belt between Mars and Jupiter. This confirms the theory that water might have been brought to Earth not only from the icy outer reaches of the solar system, but also from much closer sources. By studying the composition of these ancient ice rocks, Webb is helping us map the distribution of moisture in our system. This knowledge is critically important for future space colonizers and for understanding how unique our water world really is. One of Webb's most mysterious targets is the study of cosmic filaments, giant structures that make up the skeleton of our universe. These bridges of dark matter and gas, invisible to the eye, connect galactic clusters, forming a structure reminiscent of the neural network of a giant brain. The telescope recorded the first direct evidence of these filaments in the early universe, discovering a chain of 10 galaxies lined up along a gas fiber 3 million light-years long. By understanding how this cosmic web is built, we understand how matter in the universe is organized on such unthinkable scales. No less interesting is the study of the atmospheres of brown dwarfs, objects that occupy an intermediate position between the most massive planets and the smallest stars. Webb discovered not only water and methane in their atmospheres, but also silicate clouds consisting of glowing sand. Imagine a world where, instead of the rain we are used to, drops of molten iron or silicate dust fall from the clouds. Thanks to the telescope's spectrographs, we can literally feel the weather on these distant, eternally twilight objects that glow only with a faint reddish heat left over from the time of their birth. Finally, Webb gives us a unique opportunity to observe the death of stars like our Sun. Images of the Southern Ring Nebula showed that a dying star is actually part of a complex system of 2 or even 3 stars. Webb discerned the finest shells of gas that the star had been shedding for thousands of years, like layers of an onion. These observations allow us to predict the future of our own system 5 billion years from now. Everything we see in these bizarre shapes is our own future, written in the heavens in the golden ink of infrared light. Finally, Webb gives us a unique opportunity to observe the death of stars like our Sun. Images of the Southern Ring Nebula showed that a dying star is actually part of a complex system of 2 or even 3 stars. Webb discerned the finest shells of gas that the star had been shedding for thousands of years, like layers of an onion. These observations allow us to predict the future of our own system 5 billion years from now. Everything we see in these bizarre shapes is our own future, written in the heavens in the golden ink of infrared light. Every hour of the telescope's operation costs millions of dollars, and the competition among scientists for the right to point its mirror at one object or another is simply colossal. But the data it collects becomes the property of all humanity. Today, any astronomer from anywhere in the world can access Webb's archives to contribute to solving the mysteries of the universe. This makes the James Webb Project the most grand example of international scientific cooperation. We united as a species to build this incredible instrument, and now we reap the fruits of that daring curiosity that has always led us forward to the stars. Every hour of the telescope's operation costs millions of dollars, and the competition among scientists for the right to point its mirror at one object or another is simply colossal. But the data it collects becomes the property of all humanity. Today, any astronomer from anywhere in the world can access Webb's archives to contribute to solving the mysteries of the universe. This makes the James Webb Project the most grand example of international scientific cooperation. We united as a species to build this incredible instrument, and now we reap the fruits of that daring curiosity that has always led us forward to the stars. Ultimately, the story of the James Webb Telescope is a story about us, about our unquenchable thirst for knowledge that makes us spend decades on calculations and billions on technology for a single glimpse into the abyss. We are tiny creatures on a small planet, but our eyes are now capable of seeing light that originated long before Earth existed. This proves that for the human spirit, there are no boundaries, and space and time themselves are merely the scenery for our endless search for truth. The cosmos no longer seems as cold and empty to us as it once did. Thanks to Webb, it has become alive, dynamic, and filled with color. We have seen how worlds are born, how giants perish, and how the very fabric of space curves under the weight of invisible forces. And although hundreds of unsolved mysteries lie ahead, from the nature of dark energy to the search for brothers in intelligence, today we feel a little less alone. We have become part of something much larger than just inhabitants of one planet. We have become witnesses to the great symphony of creation. Thank you for walking this path with us to the very edge of the knowable world. Remember, every time you look at the night sky, you are looking into the past. And somewhere out there, in the unimaginable distance, Webb's golden mirror continues its silent flight, gathering bit by bit the light that will one day tell us who we are and where we are going. Stay curious, because the most important discoveries are yet to come. Until next time in our journeys through the vastness of the universe.